example here. Okay, so this is example number 1. In this, transfer function of the system is given like this: s plus 2 upon s raised to 4 plus 8s cube plus 18s square plus 16s plus 8. Okay. So what is the characteristic equation here? The denominator of this closed loop transfer function. Okay. So characteristic equation here is okay. So this is a characteristic equation. So first we need to form the Routh table. So first I will take s raised to 4. Okay. And in this particular row, now this is a even order term. So I will just take coefficients of even order terms. Okay. So 1, 18 and 8. Okay. Now next row will be s raised to 3. Okay. Now this is odd. So I will take odd order terms coefficients. So 8, 16. Okay. So now here you can see 8 and 16. You can divide this particular row by 8. So that will be modified row will be 1 and 2. Okay. Now we need to form the elements of the s raised to 2 row. Okay. So to form this element, what we do, we just take a product of this. First we take a product of this. Then we take a product of this. And we take a difference and just divide by this term. So here, this particular term will be 18 minus 2 divided by 1. Okay, so that will be 16. Okay, first I have multiplied, I have used these two rows to determine the elements of this row. Okay, so 1 into 18 minus 2 divided by 1. So that will be 16. Okay, so I will just take this here and I will put 16 here. Okay, now next element we need to find out in this row. So what I will take, I will multiply, use this color here. So I will multiply this first term. Now no element is there here. Okay, so at this point in the third row, no element is there. You can consider that as a 0 also. No issue if no element is there. So here we consider the 0 element. Now this will be the first term, 8 into 1 minus 0 into 1 divided by 1. Okay, so here I can put like 8 minus 0 divided by 1. So this is the second element of this row. Okay, 8 into 8 minus 0 divided by 1. So I will just write it as a 8. Okay. So in such a way, we have formed these row elements. Okay. Similarly, to simplify it, you can divide by 8. So you can simplify that row. Okay. So s square will be 2, 1. Okay. Now this is a simplified row. Now we need to find out the coefficient of s raised to 1 row. Okay. So to find out the elements of this row, we need to consider s raised to 2 and s raised to 3 row elements. Okay, to find out that. So so that will be this and this row. Okay, so multiply this first and then this. Take a difference of that and divide by 2. So 2 into 2, 4 minus 1 divided by 2. So this will be 3 by 2. So I can directly put as a 1.5 here. Okay, so that will 3 by 2 means 1.5. Okay, and now here 2 into 0, so this will be 0 only. 2 into 0, this 2 into this term 0. So this will be 0 only, because if there is no element, this term is also 0 in this like this. Okay, so no need to consider those elements when the 0 is other elements are not there. So that is 0 only. So we have formed elements of this row. Now s raised to 0 row. Okay, to find out the elements of s raised to 0 row, we use the previous two rows. So 1.5 into 1 minus 0 into 2 divided by 1.5. Okay, so 1.5 minus 0 divided by 1.5. Okay, so that will be 1. So I replace this term with 1. Okay, so now I have formed all the elements of the first column. I will just check their sign and I will determine that how many poles will lie in the right hand side of the S plane. Okay, so I will just take the first column here. So element, the main rows will be s raised to 4. Now this is s cube, s square, s raised to 1 and 0. So first element will be, first column elements will be 1, 1, 2, 1.5 and 1. So 1, 1, 2, 1.5 and 1. So if you see this sign of these elements, so there is a no sign change. Okay, all are positive terms. Okay, no sign change is there. So number of sign changes are 0. So we can say that number of poles lie in the right hand side of the H plane will be equal to 0, right? Number of closed loop poles, because we are considering the characteristic equation only. Okay, so that is equal to 0. So can you determine the system stability now? Is this stable or unstable system? Hello? Is this stable or unstable? It is stable system, right? Because all pole will lie in the LHP. Okay, so this will be the stable system, and number of pole lie in the right hand side of the S plane will be 0. So this is a stable system. Okay. Left hand side of the S plane. Okay, so have you understood this? How to form this Routh table? Any doubt here? Or should I explain it again? Have you understood?
Sir, explain it again.
Okay, ठीक है. So now we have uh, characteristic equation here. Okay, this one. So the roots of the characteristic equation are closed loop poles. So first now s raised to 4. Now this is an even order term. Okay. So first I will take even order terms coefficients. Okay. So coefficient of this will be 1. Coefficient of this will be 18. And coefficient of s raised to 0 will be 8. So I have considered the even order term here. 1, 18 and 8. Like this way I have formed this row. Similarly, now next I will consider s raised to 3. Now this is odd order term, right? So I will take coefficients of the odd order terms. So 8, 16. Okay, s raised to 3, s raised to 1. Okay, so all the elements are covered now, available in the characteristic equation. Now we need to form we need to find out the elements of other rows. Okay, so here what we have done now, 8 and 16, 8 and 16 is there. We just divided by 8, so we can simplify the elements of this row. Okay, so simplified elements are 1 and 2, right? Now we need to find out the elements of other rows. Okay, so s raised to 2, for this row we need to find out the element. So to find out the element of this row, we need to consider the elements of previous two rows, s raised to 4 and s raised to 3. Now how you will find out? So there is a formula to find out this first element. So you need to take the multiplication of these two elements, okay, this one and this one, minus the multiplication of these two elements, okay, 2 and 1. So 18 minus 2 divided by this particular element, okay, divided by 1. So that will be 16. So here, if you see, just consider this one. Okay. So here, this s raised to 4, a4, a2, a0 are the coefficients. In s cube, a3, a1 and 0 are the coefficients. So if I want to find out the coefficient elements of this s square row, so what I need to do, I just need to, if I want to find out the first element, I just need to I just need to take a product of these two elements minus product of these two elements divided by this element. So a3 into a2 minus a4 into a1 divided by a3. So I will get the first element of this row, b1. Okay. Similarly, if I want to find out the second element of this row, what I will do? I will just multiply a3 with a0. Now, if you see here, third element of s cube row is not available in the characteristic equation. So we can just consider it as a 0, or just consider it as a 0. So now if you take a multiplication, a3 into a0 minus a4 into 0 divided by a3. So this is the second element of this row. Okay, so that will be a0, because generally what happens, if there is no element here, so if that element is considered as a 0 element, and you can directly take this term as a second element, because a3 into a0 divided by a3 will be a0 only. So you can directly take that term as it is also. Okay, so like this way we have formed element of this row. Similar procedure can be applied to find out the element of the next row. Okay, so to find out the element of the next row, what we need to consider? We need to consider the elements of the previous two rows. Okay, we need to do the calculation with that. Okay, so let us consider this s raised to 1 row. Now here b1 is the first element in s square row. B1 is the first element and a0 is the second element. So what we have done, b1 into a1 minus a3 into a0 divided by b1 will give the first term, right? B1 into A1 minus A3 into A0 divided by B1. So that will give us the first term, C1. Okay. Now, if you want to find out the second term, what we need to consider, B1 into 0, and that third element will be 0 only. Okay, so this element came as a zeros. Similar procedure you can apply for this s raised to 0. Okay, so as you progress through the rows, number of elements get reduced in that particular row. Okay, so like this way we find out this thing. So similarly here you can see. So to find out a square rows element, we just use the same formula, 18 into 1 minus 2 divided by 1, so that will be 16. Similarly, to find out the second element of a square row, we just use 1 into 8 1 into 8 minus 0 into 1 divided by 1, so that is 8. Okay, similarly we simplified this row, divide by 8 we have done on this row, so we got the coefficient 2 and 1. Okay, now we need to find out the coefficients of s raised to 1 and s raised to 0 rows. Okay, so first we will consider s raised to 1. So here same procedure we have applied, 2 into 0. Okay, what we have done to find out s raised to 1, s raised to 1 first element, 2 into 2 4 minus 1 into 1 1 divided by 2. So this term will be this term will be 2 into 2 4 minus 1 divided by 2. So that will be 3 by 2. So that will be equal to 1.5. So this is that term. Okay, and to find out the second term, we need to multiply 2 with the 0 minus 0 into 1, so that will be 0 only, so we have put it 0 here. Now to find out s raised to 0 row elements, what we have used the elements of s square and s raised to 1 rows. Now 1.5 into 1 minus 0 into 2 divided by 1.5. So that will give us 1. So this calculation will be 1.5 into 1 minus 0 divided by 1.5. Okay. So that will be equal to 1. So like this way you can find out the elements. Have you understood?
Yes, sir.
We'll just take another example so you will get more clear idea. So this is the example number 2. So in this, we just need to use a characteristic equation that will be 2 into s raised to 4 plus s cube plus 3s square plus 5s plus 10. Okay, so form a Routh table first. So higher order term I have considered s raised to 4. So this is the even order term, so I have taken only even order elements here. So s raised to 4 coefficient, s square coefficient, and s raised to 0 coefficient. This is s raised to 0 now. So 2, 3, and 10. Okay. Now we will take s cube. So odd order coefficients, 1, 5. Okay. So there is a no element here. I will just consider it as 0. Now by using elements of these two rows, we will find out the coefficient to the we will find out the elements of this row, a square row. Okay. So first I will multiply 1 with 3. This is my first term, and then I will multiply 2 with 5. This is my second term. I will take a difference of this and I will divide by this element. Okay, so 1 into 3, 3 minus 5 into 2, 10 divided by 1. So that will give me minus 7. Okay, so I will just put -7 there only. Now I want to find out the second element of this row. Okay, so now I will take product of this 1 into 10, this is my first term, or 2 into 0, this is my second term. Okay, so that divided by 1, so that will be 10 minus 0 divided by 1, so that will be 10. Okay, so I replace this element with 10. Okay, so I have found two elements of the second row, S square row. Now I will need to find out the elements of S raised to 1 row. Okay, same procedure I will apply. I will use the coefficient of S cube and S square. I will use the elements of S cube and S square row to find out the elements of S raised to 1 row. So what I will do, I will just multiply this 2 minus multiplication of this 2 divided by 7. So that will be minus 35 divided by 10 minus 7. So that term will be 45 as 7. Okay. So I will just directly replace that term as a 45 by 7. Okay. So if I want to find out the second element, minus 7 into 0. Second element of this row, minus 7 into 0. And if there is no element in the specific row, we consider that as a 0. So overall that element will be 0 only. So here this will be 0. Okay. Then s raised to 0. For this, to find out the element of this row, we will consider the elements of these two rows. So 45 by 7 into 10 minus 7 into 0 divided by 45 by 7. Okay, so I will just do that multiplication. 45 by 7 into 10 minus 0 divided by 45 by 7. So that will be 10 only, right? So you can directly take that element here. So I will just uh, replace this with 10. So this is 10. Okay, so this element directly came here like this way. Now I have found the Routh table. Now I will analyze the first column of the Routh table to determine the stability. So first column will be 2, 1, minus 7. Just a minute. 2, 1, minus 7, 45 by 7, and 10. So you need to start from the first element. First element sign is positive. Okay. So when you go to the second element side is also positive. So no sign change. But here you can observe one sign change from 1 to minus 7. And similarly here you can observe one sign change from minus 7 to 45 by 7. So this is second. So there are two sign changes. So number of sign changes is equal to 2. So number of poles in RHP is equal to 2, right? So now here you can see the number of poles in RHP is 2. So can you tell me number of poles present in the LHP? Can anyone tell me number of poles present in the LHP? Hmm? Anyone?
4.
No. Okay. Now order of the characteristic equation
2.
is 4. So how many closed loop poles are there? If order of C is 1, so how many closed loop poles are there? Definitely 4 closed loop poles are there, okay? There are 4 closed loop poles. Now, in the right hand side of the S plane, how many poles are there? 2. So in the left hand, how many are there?
2.
2, right. So number of poles in the left hand side will be 2. So number of poles in the LHP will be order of characteristic equation minus number of poles in RHP. Okay. So order of the characteristic equation is 4 minus number of poles in the RHP is 2. So number of poles in the LHP is 2. So that will be like, you just approximately uh, draw the pole location. So that will be like 2 poles in the right hand side and 2 poles in the left hand side. Okay, so this is the approximate, not an exact location, but by using this you can determine the stability of system. So can you tell me, is this stable system or unstable system?
Unstable.
Yes, because for unstable system condition, only if at least one pole in RHP should be there for unstable system. So this is an unstable system. Okay. So here you can see, even if we haven't found out the exact pole location, then also we are able to determine the stability of the system. So is this system stable or unstable by following this method? Okay. So like this way, you can use a Routh table to form the stability of the system, to determine the stability of any system. Okay, any control system. So, can you just try this example number 3 and just tell me the stability of the system? Just form a Routh table. Have you understood? Any doubt is there in this example?
No, sir.
Okay, so you just solve this and tell me the stability of the system. Is this system stable or unstable system?
Sir, stable system.
Okay, stable system. So let us see, is this stable or unstable system? So first SQ, okay. So first we will write a characteristic equation. that will be s cube plus 3s square 4s plus 2. So higher order term is this, and that is a odd order term. So s cube. So I will take odd order coefficients, odd order terms coefficient. Okay. So s cube. This will be 1. This will be 4. 1, 4. So for s square, what I will use? So s square, even order coefficients 3, 3, and 2, right? So now I need to find out the elements of s raised to 1. So 4 into 3, 12 minus 2 divided by 3. So that will be 10 by 3. Okay. So no elements here, so that term will be only 0 only, because no elements are there. Only two elements are there. So for s raised to 0, 10 by 3 into 2 minus 3 into 0 divided by 10 by 3. So that will be 10 by 3 into 2 minus 3 into 0, 0 divided by 10 by 3. Okay, so that will be equal to 2. So this is 2. So if you form such a arrangement where in this particular calculation, if one element is 0, if this element is 0, you can directly take this term here. So you can directly take this term here. No need to do any calculation, because if this element is, if this element is 0. Okay, so first column will be 1, 3, 10 by 3, 2. So you can see all positive terms are there, no sign change. So number of sign changes is equal to 0. So that is equal to number of poles in RHP. Okay. So number of poles in LHP. Can you tell me number of poles in LHP?
3 poles.
3 poles. So system is stable system. Okay. So let us consider another example here. So so this is a characteristic equation s cube. With me, you solve and just tell me the answer. Okay. So I will form the Routh table first. S cube, s square, s raised to 1. Okay, one by one we will go. Okay. So s cube, odd order. So 1, 4. Then minus 3, minus 2. So s raised to 1 row elements. Minus 3 into 4, minus 12 into minus 2 into 1, that will be plus 2 divided by minus 3. So this will be 10 by 3. Okay, 10 by 3 only, na? So I will just replace this term with 10 by 3. Now s raised to 0. Okay, so directly you can take this minus 2 here, because this will be 0 only. So minus 2. So if you see the first column, 1, minus 3, 10 by 3, minus 2. So how many number of sign changes are there?
2.
3.
Not 2.
3.
Okay. 3. if you start from this first element sign is 1, right? Positive, sorry. So if we go from positive to negative, this is first sign change. Negative to positive, this is second sign change. And this positive to negative, that is third sign change. Okay, so number of sign changes equal to 3. So that is equal to number of poles in RHP. So there are 3 poles in RHP. So number of poles in RHP is equal to 3. So we can say that this system is an unstable system, right? This is an unstable system because all poles lie in the RHP. Okay, but now we have seen the simple examples. So in these examples, we just so this is an unstable system. So there are special cases when we form a Routh table. Sometimes what happen, uh, if first element of any row is 0, so at that time we can't proceed with the calculations, right? Okay, if the first element is 0, because for example in this s raised to 2 row, if instead of -3, if there is one 0, okay, so if you want to find out the first element of s raised to 1 row, what you need to do, you need to multiply 0 with 4 minus this term -2 into 1 divided by 0. So that term will be infinity. Okay, so that is a special case in Routh criteria. Okay, so how to handle this special case, and we can proceed with our calculation. So let us see that. So special case is what? If first element of any row becomes 0, then replace that element by epsilon, which is very close to 0. Okay, which is very close to 0, and then you complete your Routh table and count the number of sign changes. Okay, and generally the sign of epsilon is same as the first element of the previous row. For example, if in this row if in a square row the first element is 0, then I will replace that element 0 with epsilon, and epsilon sign will be the epsilon sign will be equal to the element of this s cube row. Okay, that is 1. What is the sign of 1? That is a positive, right? So sign of the epsilon will be positive. Okay, let us see one example so you will get an idea about this. Let us consider the example number 5. So here the characteristic equation of CL system is given and you need to comment on this stability. So this is the characteristic equation. Okay, so you just need to comment on the stability. So first I will form the Routh table. So higher order term is S is to 5. So that is odd. So I will take odd coefficients. Okay, 1, 1, and 3. Now S raised to 4 row, even 2, 2, 10. Okay, so now we need to form S cube. So let us see, 2 into 1 minus 2 divided by 2. So that will be 0. So 2 minus 2, sorry, 2 minus 2 divided by 2. Okay, so that will be 0. So this term will be 0. Now if I want to find out the second element of this row, 2 into 3 minus 10 divided by 2. So 2 into 3, 6 minus 10 divided by 2. So this will be minus 2. Okay, So I will just replace that with -2. Okay. Now here you can see the first element of this S cube row is 0. Okay. So what we need to do? We need to replace that element with the epsilon. So what I will do? S cube element 0 will be replaced by epsilon, and this will be keep as it is -2. Okay. Now we will proceed with our calculation. So now I need to find out the element of S square row. So I have taken S square. Now 2 into epsilon minus 4. Okay, so that will be 2 epsilon plus 4 divided by epsilon. Okay, and this term will be 0 only because wait, because here there is no element, right? If there is no element, that element will be considered as a 0. So even if you multiply epsilon into 0, so that will be 0. Okay, then s raised to 1 is, wait, what we have done, this is s cube, right? We need to take a element of this row and this row to find out the element of this row. Okay, so this will be what, 2 epsilon plus 4 divided by epsilon. This is right. Okay, 2 epsilon plus 4 divided by this, then epsilon into 10 now. I have mistakenly taken this element. Epsilon into 10. 10 epsilon. Now there is no element means here there is a 0. Okay. So 10 epsilon minus 0 into 2, 0 divided by epsilon. So that will be 10 epsilon minus 0 into 2, 0 divided by epsilon. So that will be 10. So here I can directly write 10. The second element of this row will be 10. I have directly taken that. Okay. So now we have formed the elements of the second row. Now by using these elements of second row and third s square row and s cube row, we will just form the element of s raised to 1 row. So that will be 2 epsilon plus 4 by epsilon into -2 minus 10 into epsilon divided by 2 epsilon plus 4 by epsilon. So I will just take like this. Minus 10 epsilon divided by 2 epsilon plus 4 divided by epsilon. Okay, so now if you just simplify this term, okay, so you just take a minus sign outside, divided by 2 epsilon. So you have just taken minus sign outside,